for innovation and kind of roadmap of innovation now for 4 decades. And this is a Moore's law where every 18 months you can have breakthrough new architectures that allow you to double the amount of performance you can put in a device. And last year we shipped, for example, more 22 nanometers technologies than we shipped 32 nanometers. And this year we're going to be introducing the 14 nanometer technology at the end of this year and start ramping it next year. And you might have seen in our announcement for 2013 that we have increased very significantly the CapEx, because not only we want to ramp and prepare the network of factories for 14 nanometers, but we also want to go into 450 millimeter wafers in the very near future. I would like to start with innovation number 1. Innovation number 1, we started a year ago introducing smartphones in the marketplace worldwide, and since then we have introduced 10 different models of smartphones. And we think that if we will look at this as a championship, we think that with the best phones we have introduced, we are now getting into semi-finals. The objective is to go to final, and the objective then is to win the championship. And I want to mention also the phone we introduced in Kenya 3 weeks ago for the first time. We introduced a very affordable entry-level smartphone that gives a great experience to people in emerging markets. And last week at Mobile World Congress with Eti Salat from Abu Dhabi, we announced the forthcoming introduction of a smartphone in Egypt, and you're going to be hearing about more in the African continent. And today we also announced a very important cooperation agreement with ZTE, where they're going to be working on the recently introduced new generation of smartphone architecture on the dual core that allows you to have twice the amount of performance of the previous generation and also 3 times the capacity of graphics. Second innovation, I want to talk about the new experience we are bringing, Costa is bringing to their customers in terms of serving coffee with any kind of flavors. And this is an architecture, this is a solution that is connected to the cloud, that is connected to the internet, and allows you to have a real-time understanding of the flavors customers are taking and also the feedback of their experience. And this is based on a Core i7, a very high-end architecture solution. Third innovation we have just introduced last week, what we call the Hadoop distribution software, which allows you, in combination of solutions, software, which is based on open source, and architectures and functions we can introduce in our architectures. This allows you to address one of the challenges today in the world, which is big data, which is not about only storing more data and more rich content, but it is about to be able to retrieve this rich content. And with those solutions as a combination of hardware and software, we are going to bring a great experience to the users or to the companies, which is about retrieving the data they want, once they want it, in a much, much faster way, combining this with the capacity of analytics that these solutions bring to market. The fourth one here is a very important one. It's about energy. Nothing can be done in this world without energy. And in the next 20 years, we are expecting the demand generation growth in the world on energy to be at around 35 to 40%. And the EU, as some of you know, has an objective to decrease the CO2 emissions by 2020 by 20%. And this is an industry that buys a better usage of technology, and this is what we are really doing with this company, E.ON, which is the largest private utility company in the world. It's about using the technology to optimize production, distribution, and consumption of energy. And with this, we will have a much more efficient grid, using the technology, using the smart grid, and using devices in the home to better program and plan the usage of energy, and more importantly, avoid the peaks of usage of energy. So this is a work in process, and this is a great innovation that is taking place as we speak. Fifth innovation here, it's about the experience in the cars. And this is the next generation navigation system, where for the first time you can see the navigation in 3D. And this is done thanks to the great level of performance of the architectures based on Atom that we have provided to this industry. And it's also based on the developments we have been doing in our Worldwide Innovation Center that is based in the south of Germany for the automotive industry. And the models we see here are the models that are available now on the BMW 3, 5, and 7 series. The sixth very important innovation, 2 years ago, we decided to introduce a new category in computing, which is the ultrabooks. We started it by introducing it on the second generation core. Then we introduced the third generation core last year in 2012. And you have seen a lot of different models in the world. We have started 2013 with 140 ultrabooks. So this shows an incredible capacity of the ecosystem to innovate. And what is very important is that 2 years ago, 7% of the notebooks and laptops were thin and light, and now about 1/3 of the laptops are thin and light. And this innovation has been driven by the flagship Ultrabook. And we talk a lot about technology, and we have also introduced something new 5 months ago, which is a roadmap of user experiences. So not only we talk now about technology and architectures, but we talk most importantly about user experiences. And to show here what we are able to do and what the next experiences will be looking like, I would like to invite Ulrich here on stage. So Ulrich, nice meeting you here. And I understand you have some great experiences to share with us, so why don't you show us some of them?
Yeah, we have two demos here on perceptual computing. Perceptual computing tries to improve the interaction between humans and computers. And the two demos we have, one is on voice, one is on face recognition, are about, this one addresses the problem we have with all of our accounts, right? You have Facebook, Twitter, email, all those accounts, and you have to remember the passwords. So what this one does, this one is about logging in by just looking at the computer. Oops, got to turn it on. So I have an account on this one. So if I just look at it, right? You recognize my face. Maybe I should stop talking. And since it woke up, it logged me in. Right? So what this also can do is if you had an account on this machine, you could now look at it and it would log me out and log you in.
So it will recognize my face and I will not have to type if I remember my password.
Exactly. And it would also, you can also apply this to applications, right? You could log into Gmail on your browser with your face.
Very good.
The other one that we have is about voice. So we communicate while talking to one another, right? It would be nice if we could talk to our computers when we can, but they have to react, right? And now actually they do. On this computer we have a Dragon Assistant, a voice recognition software. We have been doing this demo in English for quite some time, but now we have expanded the scope to 28 countries in 8 languages, and German is one of them. So since I can talk German, I can give it a try. What I'll do is maybe just check the weather in Munich, right? Hallo Dragon. Google Wetter in München.
Hier sind die Google-Ergebnisse für Wetter in München.
Alright, there it is.
9 degrees
centigrade.
Nice weather.
It's okay, just like in Hanover, I guess. This is just one example. The other one, just tweeting with productivity things, like for example, if this was in my home, I could, like on the wall, I could walk by and maybe check my calendar, for example, right? So let me just do that. Hallo Dragon. Welche Termine habe ich morgen?
Der Kalender wird überprüft. Ulrich, hier sind deine 5 Termine für morgen.
Right. So I could have it read my calendar appointments to me. So there's a lot of stuff you can do. Just to give you an example.
Very good, Ulrich. Thank you very much. So looking forward to have those applications on our devices. All right. Vielen Dank. We said that 2013 we will tick the box of the notebook reinvented. And we have been talking about the codename Haswell as a notebook. And I want to show you here in premise what the Haswell, working Haswell is looking like. This is going to be introduced by the mid of this. And we should be seeing a lot of the experiences that we have been talking about here and some others that are in development. So this is a convertible, detachable ultrabook, and when you have stopped working and you want to go into just consuming content, you can do it, just separate it, and you've got a great generation tablet here based on the absolute best architectures you can think of, and this will be any of the Haswell flavors that is going to be introduced later on this year. With this, I want to go on stage to talk more about innovation, not about the products that exist today, not about the products that are coming in the next couple of quarters, but a bit more down the road, next year, 2 years down the road. So Martin Curley, who is Professor Martin Curley, who is Vice President and Director of our Intel Labs in Europe, Middle East and Africa. Martin, what do we have coming that is being developed today?
Great, Christian, thank you very much.
Thanks so much.
Thank you. So good afternoon, everybody. I'd like to build on all the exciting innovations that Christian has talked about and share with you some of the things that are coming in the pipeline. So we only have 20 minutes. We'll talk about how we're working to substitute photons for electrons to reconstruct or re-engineer the data center of the future. We'll talk about how actually right here in Germany we're changing the future of displays, or how we actually access and drive content to displays. We'll talk about how we're trying to out-accelerate the ad hoc innovation that we see in cloud computing. We'll talk about how we're changing and working with partners to change our cities of the future. And that's what we're doing actually to make Europe much more dynamic and much more competitive. So I'd like to introduce you first to the Intel Labs network. And this is a network of more than 40 labs that we have across Europe. We've quadrupled the Intel investment in R&D over the last 2.5 years, grown from 800 people to more than 4,000 people. Probably the center of gravity is Germany. We have 7 labs and development centers in Germany, but recently we've invested heavily in France and Finland, in the UK. One of the key concepts that has been explored in the whole CeBIT conference is the idea of shared economy. And one of the concepts that we very much embrace in Intel Labs Europe is the idea of shared value. Michael Porter, a famous Harvard professor, has been writing about this for the last couple of years. That's the idea that we can reconceive the intersection between society and corporate performance. So any of the innovations that I'll talk about that are in the pipeline are done with a process of co-creation. And I guess the strength of what we do is actually the number of collaborators that we have. Today we have more than 400 collaborators in our network. Some of you will be familiar with FP7, which will shortly be replaced by Horizon 2020. But that's the European Union's Open Innovation Programme. 4 years ago, Intel wasn't in the top 1,000 participants in FP7 and ICT. Today we're one of the top 10 players. And we built a strong ecosystem that not only has high Intel architecture affinity, but also has high Intel architecture competency. We've tried to align our research agenda and innovation agenda with what Europe wants to achieve. Some of you will be familiar with Europe 2020, which is the follow-on to the Lisbon agenda. It's about making Europe the most dynamic knowledge-based economy in the world. There are 7 flagship initiatives. We've aligned our research agenda and innovation agenda with actually 5 of those. And our whole philosophy is if Europe wins, Intel wins. We were very pleased to be in Brussels yesterday President Barroso and 4 commissioners announced a new grand coalition to create digital jobs, and Intel is delighted to be an integral part of that. One of the key things that are practices that we use, this whole presentation is about innovation, is the idea of triple helix innovation. This is a concept that was first introduced by Henry Eckowitz, who's a professor in Stanford. The idea is very simple, is that we have governments, industry and academia working together to drive structural changes beyond the scope of what any one organization can do. And what we've learned over the last 3 years, this is a very effective way of actually getting things done, of sharing risk, sharing resources, doing things with better quality, and doing things much faster. So let me give you one example. Cloud is, of course, extremely exciting. It's moving very fast. We're really just in the early days of actually what can be achieved. In Cloud 1 of Framework 7, we worked together with SAP, the University of Dortmund, and many other partners to architect a research project called SLA and SOI, Service Level Agreements over Service-Oriented Infrastructure. And what we wanted to do here was to actually implement a regime of machine-readable SLAs. So if I'm in business, I want to consume a service, or actually use a service or deliver a service that has a business SLA, that I can nest that in an automatic fashion and connect it directly to the infrastructure and the service level agreement that would run at the infrastructure layer. The output of this has been a new standard called OCCI, Open Cloud Computing Interface. As we think about where is the value going to come, we have a vision of 2020, something we call IDD cloud, interoperable, differentiated, and dependable cloud. I don't think there's anybody in the room today that would bet their life on the cloud. But I think by 2020, we could be driving in autonomous cars that are linked together, that we depend on the cloud. So these kind of works, Intel on our own, we're a large company, the world's largest semiconductor manufacturer, but we can't create the future. But by working with partners and with governments, and even the EU, Neelie Kroes, the Commissioner for DG Connect, the Digital Agenda, I think got it spot on at Davos. You know, walls in the cloud will make all of our lives harder. Through openness and moving to an interoperable, differentiated and dependable cloud, together we can create a great future. So we talked about triple helix innovation. What's quadruple helix innovation? Well, this is an extension of this, and this is where we start to actually involve users and citizens in the innovation process. One of the key trends that I think we've all seen is the move to user-centered innovation. And in fact, if you look at YouTube and so on, the consumer is now moving to become a prosumer. So we're applying this principle in a number of different areas. Probably the area where it's actually most effective right now is in the area of cities. Cities seem to be at the confluence of 3 megatrends. Digitization, which is being driven by Moore's Law. You know, Moore's Law is colliding with virtually every domain. Sustainability is a new paradigm. Cities have lots of people, they have lots of pollution, lots of problems, but actually they're really quite efficient if you look at comparing the energy efficiency, the resource efficiency of people living in cities compared to regions. And lastly, as we look forward, one of the main paradigms that we see is the idea of mass collaboration. So mass collaboration from people to machine, but probably what's going to dominate is machine to machine. And we see a great opportunity to deploy new solutions that change the future of our cities, that we could think of the city as a computing platform. Bill Ford at last year's Mobile World Congress made an interesting statement. He's the president of Ford Motor Company. He said the car is now part of the network. We're not far away from actually the citizen being part of the membrane of the city, where a citizen can make a choice to actually participate in the digital nervous system of the city, either some sensor on his phone, or potentially think of the scenario where there's pluvial flooding in a city. A citizen can take a picture in real time, upload that to the city, and the city can respond with that information. One of the things that we're doing with Dublin City, where I live, is launching an application with Trinity College called CityWatch. And this combines with a platform, a research platform that we've deployed in Dublin. It's an ambient intelligence platform. Here at CeBIT, everything is about mobility. We're currently in the decade of mobility. We've gone from the mainframe to the PC to the internet to mobility. the next era of computing is about cyber-physical systems. We're working in Dublin, we're working in London, we're working in Barcelona, we're working in Beijing to create the next era of innovation in cyber-physical systems. And here's just a schema that shows actually some of the usage models that actually might happen in the city of the future. Of course, you've got to build it on secure, scalable, and infrastructure that protects the rights and the privacy of citizens. But you can imagine actually that you have ambient intelligence sensing devices located through the city. You can imagine vehicles that could be private citizens' vehicles, or they could be actually vehicles, let's say, for refuse collection that have sensing devices connected to them. In fact, we're doing this in several cities around the world. Citizens can be participating in the process. And there's many other sources of information, and this is kind of fed into the whole big data world. And the overall objective is that we can look at the city as a holistic resource, where ultimately we can provide much better services, drive resource efficiencies, and improve a better quality of life for individuals. Double helix innovation is another derivative of the term that I've been thinking about. Over the last couple of years, Intel has been working to reshape the way that we collaborate with universities. And right here in Europe, we have created a new kind of institute called the Intel Collaborative Research Institutes. And we have two in Germany, one computing at the University of Darmstadt with Case D. And over 3 years ago, we launched a new visual computing institute at the University of Saarland in Saarbrücken. And Saarbrücken actually is not a mainstream city, but the University of Saarland won a global competition to host this institute. And we were just delighted to see that at CeBIT, the Grand Innovation Award this year was won by a researcher based at the Intel Visual Computing Institute. So at this point, I'd like to introduce and ask Alex Loeffler from the IFECI in Saarland. Alex is a principal investigator, also with DFKI, and he is the winner of the CeBIT Global Innovation Award in 2013. Alex. So Victor Hugo once said, there's nothing as powerful as an idea whose time has come. And I think Alex actually has an idea whose time has come. So please start to tell us about display as a service.
Thanks for having me. Well, display as a service is mainly about revolutionizing the way we connect to displays. Usually there's a one-to-one connection between displays and the sources of those pixels.
So you mean there's a physical video cable, you have a source and you have a display or an output?
Exactly, there's a video cable, there's a dedicated video connection via Wi-Fi or an integrated device that combines the two of them. And we want to make this more flexible by transferring this functionality to the network. And
so wires are going to disappear? Is that what you're telling us? We won't need these video cables in the future?
Yes, we can do that wirelessly as well because we're using the standard network, and we can do that using Wi-Fi as well.
So this is starting to sound a little bit like science fiction. Tell me how this all might work.
Well, we use a virtualization concept basically. There's video sources on the one hand that are available as resources in the network, and on the other hand we have displays that are supposed to display those pixels. And we've just used the network to combine the two of them, map pixels to displays arbitrarily and how we want it to. To display walls as well, we can play out to several combined display devices. And
do all of these screens have to be the same size, the same manufacturer, the same format?
No, not at all. We can use multiple devices, heterogeneous devices, a wall made up of, for example, LCD screens, tablet computers, all that together as one large display to show content on.
So we know tablets and ultrabooks, some of the beautiful ultrabooks that Christian show, they all have processing power, they've all displays. But what about projectors and desktop monitors? Mm-hmm. Can they be integrated?
Yes, we assume displays to be smart today. So basically, we assume them when you buy a TV in an electronics store today. They basically have an integrated display. Well, not only the display, but also a processor and the ways to receive pixels from the outside, process them, and display them ultimately. But if devices don't have that capability, we can emulate that by attaching a small piece of hardware, like, for example, this Intel next unit of computing. and make every display or every monitor and projector smart in that connection.
So it sounds like a great idea. When might you be ready to demo this, Alex?
I have a confession to make, Martin. We're actually using the same system the whole time. So this presentation that you see is already displayed using Display as a Service. My colleague Luciano over there is having a small application that uses...
You're making this up. You know, nobody told me about this.
No, we're not making this up. So we made this projector of the press conference a smart display by attaching one small device like that. And yeah, we were able to display not only the one content, but combine multiple content from the network. For example, we could add a video to that and use all kinds of sources to combine it on one virtual display. For example, this video.
Oh, excellent.
Yeah, the video is coming from a whole different computer, just connected by the network.
So I've been eyeing up this very nice Dell ultrabook here. You know, what do you want to show us with that, Alex?
Yeah, I wanted to show with that well, this is also just connected using the network, and we can add that as a third resource to this screen. Maybe we can show that now. So we're using a wired network. We could do that wirelessly as well, but in this press conference
So
setting,
why aren't we doing it wirelessly here, Alex?
Yeah, that's just to be safe in this setting that we're, well, we don't get interruptions used by other phones. So we can, you see this is full and interactive. We can interact with this content, showing pictures of beautiful Saarbrücken, by the way. And yeah,
so this looks really easy, but I bet you can't, now that you're using it, I bet you can't use that as an output, as a display itself.
Actually, we can. Let me show that. I'll just
it's too good to be true. If you're interested in seeing more about this technology, it's on display in Hall 9. And there's a very interactive, nice display of this technology.
So what we see here, we have this, we're now using this device as an output display, and we're mirroring the same content over here. So it's kind of stuck now, but yeah. We're using the same content and can multiplicate that in the network because it's just a virtual resource mapped to virtual devices. And I told you before that we're able to do that heterogeneously as well. So what we did before is we configured this ultrabook to be an extension of the available projection here. And what we can do basically is use this device as an extension and can move and heterogeneously use the screen. Well, now, yeah.
So, ladies and gentlemen, you've just seen the future display technology, and remember where you saw it first. Can I please give Alexander, a real warm round of applause and congratulations. We're all very proud of Alex. Thank you. Well done. So in the last minute that I have here, I'd like to finish by talking to you about actually the future of the data center. One of the areas that we've been thinking about innovating is in the area of silicon photonics. And very traditionally, labs like Intel Labs or IBM Labs or Bell Labs, if a technology didn't fit with an existing business unit, it actually wasn't used. So what we've done at Intel is create a new venturing process, and one of the first outputs of the venture process actually was the ThunderBolt technology, which actually went directly into the Apple products. But the first real venture that we're running is something that we call our silicon photonics operation. And this is a technology that we think is going to revolutionize the data center. Michael Schreis from MIT talks about innovations, not innovators, innovating, it's customers adopting. So in this innovation effort, we're working very closely with Facebook. We've already delivered engineering samples to Arista, and this diagram that you're seeing here actually is the first mechanical prototype of a photonic rack. This has creates the opportunity to really transform the data center, and in particular allows us the opportunity to disaggregate compute, network, and storage for the first time in high-performance data centers. So with that, I'd like to conclude a brief tour of some of the things that we're working on in Intel Labs Europe. And it's a great pleasure to actually introduce Gordon Grealish, who's our Vice President of the Enterprise Solution Sales Group and the Global Director of that group, who's actually going to tie all of this together, give us an external outlook and introduce the concept of the third industrial revolution. So please welcome Gord to the stage.
So, thank you. To start, I'd like to actually show a short video that reviews what happens on the internet in a minute. If you could please. Showed that video is because we're at a very interesting time. We as human beings like to think that today is just like it's always been, that, you know, we've had internet for a long time, that it hasn't changed, and yet it's actually gone through massive disruptive change. The internet of today is very different from the internet of 2 years ago. In fact, all of the information in time until 2 years ago is less than what we've produced since then. So we're in an amazingly disruptive pace. And this is something that Jeremy Rifkin and others have referred to as the third industrial revolution. And it spans molecular biology, the internet, energy sources, etc. But the point of these industrial revolutions are, they're not the 5-year variety or the 2-year variety. They're something that takes decades. A good example, if we look at the second revolution, was around new forms of electrification, for example. Early on, in the early part of the 19th century, we had people experimenting with electricity, coming up with new machines that use this exciting new technology. But it really took until the first decade of the 20th century, where we got to AC power, we got to standard generating units, etc., for it to really turn a corner. At that point, by the next 20 years, we had a transformation of the world. Place where you didn't build a house that didn't have electricity, that it was normal in every street, in every device, that labor-saving gadgets were coming out everywhere, and people wouldn't have recognized the world of 20 years before. And that third generation of the third industrial revolution is really where we are today. This is disruptive, this is really big. Now, really big means things change, and what you see here are just within the IT industry, companies that are being impacted in positive and negative ways by this level of transformation, this pace of change that we really can't get to grips with as human beings. We really struggle sometimes to think, well, it can't be changing this fast. And we think this is because of a number of issues. It's based around Moore's Law, and what Moore's Law has done is there are technical barriers that you pass where you move from things being impossible to things being mandatory. Those are also economic barriers, where they become outrageously expensive to ridiculously inexpensive. And these cause what we call tectonic shifts. This is a dramatic structural change, an earth-changing transformation. And these tectonic shifts are driving, these are based on technology, but they're driving transformations of industries. Now, the first is big data. You're going to hear, as you walk around the grounds of CeBIT, you're going to see thousands of people talking about big data. And it's the kind of thing that we like to kind of put our quotes around it because it really is kind of poorly defined, but it's really important. It is data on a scale of volume and velocity and value such as we've never seen before. You look at some of the numbers here and they're really big. The interesting part is those numbers are probably twice the size of what they were 6 months ago. You know, 7.9 zettabytes of information was only 1.8 zettabyte in 2011. And a zettabyte is one with 21 trailing zeros, so it's a really big number. If you look at the value to US healthcare, that's gone from $600 billion of just using the information we already have. And as you look around the world, we're seeing these incredible transformations, and they're having real effect. NextBio is a company in the genomics business. They've gone from taking weeks to taking hours to decode DNA. What that's done is it says the cost of decoding DNA drops down to $1,000. At $1,000, we're talking about saving lives, of individually targeting diseases in ways that couldn't have been done before and is now within the reach of the average person. Likewise, we're seeing with China Mobile here, they have over 30 terabytes of billing data. That is now available self-bill, so self-service. I can go in and if I'm a subscriber, I can find out exactly what was happening with phone calls 5 minutes ago. That would not have been possible even 2 years ago. So this is huge. The problem is, how do I afford this with all these massive numbers? Well, Intel is engaging in solving these and starting from the point of view of the customer. We look at this and we say, well, how do I store this volume? How do I process this information quickly enough? How do I get it in the hands of the people who need it? Not just the executive, but everyone who needs it. And how do I manage the skills required? And we're addressing it, you heard earlier about Hadoop and the approach there. Well, Hadoop can have a massive disruptive effect in reducing the cost of big data. But we're also supporting it across many other areas of software. We're supporting it with processing, with storage. And these are disruptive changes that really say, I can't do big data the old way, the traditional way of handling information. I need new disruptive ways of managing it. The second area is cloud computing. Now, that old thing. Cloud computing was first used as a term in 2006. So that old thing ain't that old. This is something that has actually been a very rapid transformation. And it's two things. It's a set of technologies and an approach that gives me a flexible fabric of computing I can land applications on. And it's a business model, software as a service, and both of those we need to understand. All of this needs to be automated because I can't deal with the volumes in a manual sense. It needs to be federated so that I can deal across physically separate data centers. And it needs to be client aware so I can deliver optimal performance and solutions. The numbers, as you see on the chart here, are very, very big. I mean, even you look at power there, $27 billion in additional power costs by 2015, 15 billion devices. These are huge numbers. And we need to deliver these if we're going to solve the problems that we are aiming at here. We're going to have to deliver this with open, interoperable standards. We're supporting that through working with end customers. The Open Data Center Alliance has done amazing things in defining the solutions around business problems, not so much technical problems, but what is a service level agreement for cloud? How can I onboard and offboard from a cloud? How can I ensure that my information is legally stored and is secure? All of those kind of issues are being dealt with by the end customers. We also work with the Open Compute Project, as you heard from Martin, the OpenStack Software Cloud Alliance, and a number of other areas to define open standards-based ways of approaching the issues on the cloud. At the other end of the spectrum, we work with the software community to deliver real solutions. Solutions that are defined and documented in a way that they can be replicated by others. And then finally, we deliver a huge range of technologies from SSDs and fabric and network and software to compute and storage. So all of these things are critical to enable an open, interoperable cloud. The third area is the Internet of Things. And I think the setup from Christian and Martin was really clear on this. We're going through the point where these devices disappear, they connect, they're secure, and they enable smart infrastructures, smart machines, and smart cars. They enable an entire legion of new technologies to be connected, manageable, and intelligent. And we're focusing on several industries here: automotive, retail, and manufacturing. In each case, you move towards connected devices, intelligent devices. And to do that, we see a number of common challenges, but something that's really unavoidable. We have to move in these directions to solve the issues that are facing us, such as sustainable cities. So this transformation to everything being connected and information being the currency is something that you're going to hear a lot. As you go around the different booths at the exhibition, you'll hear many people speaking about it. We think to do this, though, you need to do this in an open, interoperable way. So we've established an intelligent systems framework based around standards and working with our ecosystem to deliver this in a way that's replicable and reduces the kind of unique costs and proprietary approaches that many have taken in the past. We're delivering vertically integrated solutions, and our ecosystem is delivering industry solutions here that span many companies. And finally, we're leading the ecosystem in defining standards to ensure that this stays open, interoperable, and innovative. The fourth area, is the client continuum. We've already talked about this incredible array of new innovative devices. And in addition to these, you see many desktop devices, wall-based devices, devices that disappear. Those devices need to interoperate, they need to continue to innovate, and to aid that, we're working in a number of areas of emerging technology. You saw voice, perceptual computing, facial analysis. We're working as well with augmented reality. And the goal here is not to make these special, quirky little things, but to make them an integrated part of how you interface with these new innovative devices. Much of that in the room today, and you can expect to see this continuing to evolve very quickly. The way we're doing this required, frankly, a very deep change internally. Traditionally, Intel would deliver a platform, a reference platform, to our industry partners, and hundreds of companies would build computers. What we're doing now is working at a much higher level of specification, and as an industry, this is working out extremely well. What it says is that we need to first look at what is the user experience that we expect. We can't have the huge variability we've had in the past. There has to be a user experience that is delivered to the end customer. That will specify the systems and software required, and that in turn will develop what silicon is required and how we develop it. So we really are taking the lead now from ethnographers, social scientists, people who understand how you perceive differences and how we can improve your actual experience of the technology. This is a huge transformation for Intel as a company, and what we've seen is it has been embraced by our partners. And you see the results here of superb solutions being delivered in this partnership that really focuses on user experience. The fifth shift is one that isn't quite as pleasant and supportive. This is security. And you're seeing security actually being exacerbated by the tectonic shifts that I've spoken about. Big data means really big attacks, right? I mean, we have much more of a surface to attack. The cloud has resulted in crime as a service. We now see malware attacks being in the hundreds of billions of dollars